So let's see. Oh, special triangles. So we're working on trig with special triangles. So I'm going to put my SOHCAHTOA on the top in case you don't have that yet. Some of you do, which is great, in case I need this. So let's see, I got my 45, 45, 90. We know this, right? The legs, you multiply them with the square root of 2, you get the hypotenuse. Here's my 90 and the leg, that's my h. So let's see here. What's the sine of 45 degrees? Yeah, what's that going to be? Yeah. So why is that 2 squared? What is that going to be? How come? Now, let's just quickly review. How do you rationalize the denominator? I multiply the bottom by the square root of 2 because that's how we pop it out of the radical, right? The square root of 2 times the square root of 2, it's got to be 2. But I don't want to change the value, so if I multiply it by 1, I'm not going to change the value. So same over same is 1. So I get square root of 2, rad 2 times rad 2 is 2. Nice. Okay, what about the cosine of 45 degrees? Well, that would be the adjacent over here, right? That's the opposite. If I'm relative to this 45 degrees. So what's my cosine? What, Michelle, what do you think? Same thing, right? So it's going to be 1 over the square root of 2, and then we rationalize that denominator. How about the tangent of 45 degrees? What's that going to be? So tangent is opposite over adjacent. What's that going to be? What's it? What do you think of, Connor? 1. Opposite over adjacent is 1 over 1. Always simplify. So there we go. So if you have a 45, 45, 90, we can find the different values, sine, cosine, tangent. Oh, that's beautiful. Oh my gosh. All right, let's look at the 30, 60, 90. Wow. Okay, so let's look at the 30-degree angle now. Okay, here's my hypotenuse. Now with this angle, there's my opposite, there's my adjacent. So I've got, so just to remind myself how the ratios work. So what's the sine of 30 degrees? Opposite over hypotenuse, right? Opposite over hypotenuse. 1/2. Opposite over hypotenuse. And I guess we should review this too. If my hypotenuse is 2, the side opposite the 30 is half of the hypotenuse. That's where the 1 comes from. And the shorter leg times the square root of 3 gives me the longer leg. So that's where the leg comes from. Okay, so cosine 30, that's adjacent over hypotenuse. Adjacent over hypotenuse. Square root of 3 over 2? Yeah? And then, ooh, tangent. Tangent is opposite over adjacent. Opposite over adjacent. Oh, but I can't leave it like that, right? Let's rationalize that denominator. Square root 3 over 3. 1/2 rad 3, square root 3 over 3. Now we can work on the other angle. We're going to work on the 60-degree angle. Now, relative to him, this is the opposite, and this is the adjacent. Hypotenuse stays the same. So sine of 60, opposite over hypotenuse. So square root 3 over 2. Sine of 60 is adjacent over hypotenuse. 1 over 2. Tangent, opposite over adjacent. Square root 3 over 1. I can simplify that to just the square root of 3. Okay. Yes? That's not so hard. And then I have a little table. I think that's next. It's a little summary. We didn't really talk about the 0-degree ones or the 90-degree ones. So here you go. The sine of 0 degrees is 0, and the sine of 90 is 1. The cosine of 0 is 1, and the cosine of 90 is 0. And tangent, 0. What? So a lot of this is a little hard to understand without seeing the graphs of these things. And when you get into trig proper, if you take algebra 2 trig next year, or if you take a pre-calc class next year with trig, you'll learn a little bit more about why we're getting this. I can tell you real briefly that tangent is the same as sine over cosine? It just is, and we can prove that when you get to that class. But sine over cosine, 0 over 1 is 0. But 90 degrees, 1 over 0. Oh, wait a minute. 1 over 0? Can I do that? Cannot divide by 0 in mathematics, correct? Yeah? Are you there? Anybody there? I can't, so it's undefined. We'll learn a lot more about these triangles. You will have to memorize these in that class. You're going to have to know these. Not necessarily for this one, but I would like you to know how to find them. So if it's like, oh, I don't know, what's the sine of 30 without using my calculator, really? You can go and just build yourself one of these triangles and figure it out again if you need to. So I'm not requiring memorization just yet, but you will. You will have to someday. Okay, so let's solve these triangles. Now we're going to do them using trigonometry. Now we know how to do it without trigonometry, right? If AC is 7, what is BC? It's a 45, 45, 90. Yeah. 7, right? It's also isosceles. These would have to be the same. What would AB be for that example? 7 rad 2, right? We have those rules. So rather than doing that, we're going to use, we're going to use the trig. So let's see, if AC is 7, that's our given, and I'm looking at finding BC. So it doesn't matter which angle we're referencing, they're both 45, but that would be an opposite, right? And that would be an adjacent. Okay, so let's see here. I'm looking at this. How do we do this? We're going to run here. Tangent, right? Tangent of 45 equals the opposite over the thing I'm trying to find, BC. So BC equals 7 over the tan of 45. What is the tan of 45 without the calculator? I'm looking at, you can look at a little chart here. What's the tangent of 45? 1. So what is that? 7. Which we know by their special right triangle rule, but we can get it through using trig function. Let's try a different one now. If BC is 10, BC is 10, what's AB? What's this? Now we know what it is, right? It's 10 radical 2, just because of special triangles. Let's try it with the trig. So this is what I'm trying to find out. That's an adjacent, that's a hypotenuse. Cosine of 45 equals 10 over the thing I'm trying to find. So I can swap places. What's the cosine of 45? Can we figure that out already? Okay. Uh-oh. How do I simplify that? What do you do? Yeah, I'm not using the calculator now. We're using plain ordinary math. There's a couple of ways to figure this out. Why don't we write it this way? That's the same as 10 divided by the square root of 2 over 2, right? Fraction? Well, how do you divide fractions? What's that the same as? Multiplying? Hello? How do you multiply? How do you divide fractions? Multiplying by the reciprocal. Whoops, the reciprocal is 2 over rad 2, which is 20 over rad 2. Except I can't have radical 2 in my denominator, can I? So let's rationalize it. I'm getting 20 rad 2 over 2. Ooh, look, this simplifies. 10 rad 2. You get there eventually. It's still not going to work. Why can't I just remember 10 rad 2? Oh, you can. But it's just playing around with the different trig function. All right, let's try this guy. 11 rad 2 is what? It's, yes. 11 rad 2 is what, AB? So what's BC going to be? Just knowing what we know? You guys sound very sleepy today. Yeah, what's it going to be? Yeah? 11, because I divide by the square root of 2. So let's use the function here. Oh, goodness. So I'm trying to find this guy. Cosine. Okay. Okay, so that means that x is 11 rad 2 times the cosine of 45. What's the cosine of 45? Okay, so what am I going to get here? I'm going to get 11 times 2 over 2, right? Goes away, there's 11. So it kind of works. Yeah. Yeah, do it. Go ahead. Type in 11 rad 2 times the cosine of 45. See what you get. Yeah. Is that surprising? Now we believe it. If the calculator says it's true, now I believe it. This is like this is a remnant from when we didn't have calculators to figure out trig. This would be faster than trying to look it up in a table. But it's also, again, it's a number sense thing. You kind of understand what these numbers are. Yeah? Well, it's radical 2 over 2. Yeah? Let's see what's going on for this last one, and then move on from here. What's the last one here? AB is 10. Ooh, so what is AC going to be? It's going to be what? 5 radical 2, which is 10 over the radical 2. Once you rationalize the denominator, you get 10 rad 2 over 2, which is 5 radical 2. Oh, okay, so let's see what I got here. I'm going to put it over here for AB. So that's a sine, right? So the sine of 45 equals x over 10, right? AB over 10. So it's 10 times the sine of 45. What's the sine of 45? Okay, oh, well, that's easy. That goes in right. 5 radical 2. So it's just ways of finding things without you being so dependent on a calculator. We'll just do a couple of these just to kind of prove the point on this side. So if BC is 7, what is AB? You can use either one that you want. Let's go here. So I have an opposite and a hypotenuse. Sine of 30 is 7 over x. The sine of 30 is a half, isn't it? How do I do this? X equals 14. Does that make sense? The side opposite for 30 is half the hypotenuse, so it's that times 2. Yes. And so, and we get the general idea. So I'm going to leave the rest of them as an exercise for the user, but we can use these special values of the special triangles to find things without a calculator. Okay, this topic, angle of elevation and angle of depression. This is an awesome topic. These are applications of trig in real life. Now, what is an angle of elevation? If you're looking at something, here's your eyes, your line of sight, you're looking straight across, that's your horizontal. But then you have to look up at something. So this angle of elevation is the angle that you're looking up at some sort of object. Angle of elevation. Now the angle of depression is the opposite thing, but be careful with angle of depression. It's not a sad angle. It's just that it's looking down. That's what depression means. You're always starting from the horizontal, and then you're looking down. That's the angle of depression. Now lots of people want to put it here, but it's not there. It's you're looking straight and looking down. So you're always starting at the horizontal. You're either looking up or you're looking down. And this hopefully will make more sense with a couple of examples. So let's see what we got here. Angle of depression. I don't know what this is, some kind of a thing here. Okay, so if you're on the ground and you're looking up at a building, so that's you, and that's your eyes. You're looking up, that's an angle of elevation. If you're at the top of a tree, we love doing crazy things. You're at the top of a tree here, whoops, up here, top of a building, sorry, and you are looking down, that is the angle of depression. Start at the horizontal, I'll call that one alpha, and look down. And I'll call this one theta. Now, what can we say about alpha and theta? Do we notice anything about those two angles? Owen, why are they congruent? Because why? They're alternate interior angles of parallel lines. Can we see that they are that? Okay, so this one, if we're looking straight across, we're assuming perfect straightness. Whoops. These are going to be parallel because they're perfectly horizontal. If you kind of extend this as the transversal, there we go, alternate series. Yeah?
I don't think we have to assume that you said it has to go horizontal.
Yes, right. We don't have to, well, yes, you're right. We're assuming perfect horizontal is what we're assuming. And if we assume that, you are correct. Because, you know, and when is the ground perfectly level? Never. But if for our example, we're assuming the ground is perfectly level. So, yes, they're the same thing. So that's kind of an interesting thing. What do we notice? Yes, they are congruent because of that reason. So that's good to know. So here's an example. Let's see, we got to do here. Look at it. He's from a point on the ground 25 feet from the foot of a tree. So here's the guy, here's the tree. He's 25 feet away. We should use units. The angle of elevation. So that means now, you could, to be exact, you would have to say, well, how tall is he? So as for starting purposes, let's assume he's on the ground and his eyes are right here. So we're not going to worry about his height. And he's looking up. That's an angle of elevation. We're telling us it's 32 degrees. How tall is this tree? So we have to notice, wait a second. We have a right triangle. If, again, we're making assumptions, perfectly flat ground, perfectly upright tree, then this would be a right angle. So I could use tree because my don't know is an opposite. What do I know? Is this an adjacent or an hypotenuse? Adjacent, because here's my hypotenuse. So I can figure this out. Tan 32 equals the opposite, which is the I don't know, times 25. Solve that for x by multiplying both sides by 25. You get your cal. Now you can do your calculator. So let's see, 25, what's working? Tan 32. And I'm getting approximately 15.62. Let me read the question carefully. It says to the nearest foot, right? So rounding matters now. Nearest foot, 16 feet. Right? The answer to this question, to the nearest foot, how tall is it? It's about 16 feet tall. So we can use the trigonometry to help us solve real life problems. Now, even in real life, where things aren't perfectly level, that's not perfectly straight, if you only need an approximation, this works. Right? Okay, maybe it's not exactly that. Maybe it's not exactly that. But you'll be close. So you can figure out those kind of heights. Question? I saw somebody with a question. Yeah. Are you in the right mode? Make sure check your mode, check your mode. Did you get that too? Yeah. I know that. Yeah, I really hope you fail without at least one time. Because I'd rather you fail now before when you're all wrong, like, oh. Okay, let's, oh, good kitty. Aw. On the top of a barn, 25 feet tall, because what else would you be doing than sitting on top of a barn? There you are. You see a cat sitting here. Hello. Hello. The angle of depression. Be careful, be careful, be careful. Because, you know, usually I'm not giving you a fancy little diagram. You've got to figure this out. So you say, okay, I'm at the top of a barn. Here's the barn. I'm at the top. And that's 25 feet tall. Here I am. And then I see a cat over here, right? You could draw the triangle. You know what most people want to do with their angle of depression? They want to put the 40 here. Is that where the 40 goes? You are looking straight across, and then you look down. Your angle of depression, if you were doing this without a picture, it's right here. Be careful, be careful, be careful. Write this down somewhere. Be very, very careful with angle of depression. The most common error is you're going to put it in the wrong place. You want it to be in the triangle. It's just a natural thing to want to do. So it's not. It's you're looking straight and then it's looking down. But I'm going to use the fact that angle of elevation and angle of depression are congruent. I can see I like making it a little deep, that's so I can see my ultimate material. This is also 40 degrees. So I can get it in the triangle, just make sure you're putting it in the right spot. What do they want to know? How many feet is the cat from the barn? So that's my x. So I can see my triangle now. I've got an x here, a 25 here, and a 40 degrees here. So what do I have? An opposite? To find an adjacent. So that's a tangent. So tan 40 is 25 over x. So x is going to be 25 over tan 40 in my little swap. And then, here it is. 25 divided by 40. About 29.79. Let's go back and read the question. What's my rounding?
But
Nearest foot, so what's that going to be? 30 feet. Now, even if it didn't tell you to the nearest foot, in real life, you can tell somebody, yeah, that cat's got 29.79 feet to go. Because we care about how far that cat, we can spin that. Because, yeah, the cat has about 30 feet. So there is a little bit of common sense with the rounding, but definitely, if it tells you what to do, you do what it tells you. I don't know why we need to know that, but we do. John wants to measure the height of a tree. He walks exactly, yes, because he's got some kind of measurement tool, exactly 100 feet from the base of a tree, and he looks up. The angle from the ground to the top of the tree is 33. Now, if you don't draw a picture, this is extremely difficult. So how do you draw a picture? Yeah, what do you do?
well, it would be a good line.
You make a tree, right? This is what he wants to measure, right? So there we go. Start with that. He walks exactly 100 feet from the base. Now, assuming this guy is a normal person just walking on the ground, and of course the ground is perfectly straight, 100 feet. From there, he puts his eyeball, he's right on the ground, he puts his face right on the ground, and he's looking up. How much is he looking up? 33 degrees. And I guess he's got a special, what is that little tool? Sextant, I don't know, there's a name for that. That tells you the angle that you're looking up. He's got all these things, but he does not know how tall the tree is. So, do we have a picture? And I think I drew a picture too here. Let's see. Yeah. Oh, that's similar. Okay, so now I have to figure out what kind of to use. And again, opposite of the J things, right? So tangent. So tangent of 33 is the height of that tree over 100 feet. So 100 times the tangent of 33. Now how best to do is 100. Whoops. 100 tangent. You got it already? We're getting 64.9. Nearest foot though, right? Nearest foot, so that's 65 feet tall. Yeah?
Maybe it's a redwood.
What?
Maybe it's a redwood.
Maybe. That's a pretty tall tree. 65 feet, is that tall? Alrighty. Maybe. Okay, the angle of depression. From the, they love lighthouse questions. They love questions like this. Alright, so you're at this, you know what a lighthouse is, right? It's the thing with the whatever, and it turns around and that up. So here you are at a lighthouse. It's 40 meters tall. The ship at sea, and again, we're assuming everything's perfectly level. It's not on a hill. It's right at sea level. And we've got our ship at sea. Oh, there it is. And how far away? To a ship at sea. Angle of depression. Uh-oh. So now I'm up at the top here. From the top. So remember, start by the horizontal, and then you look down 18 degrees at this ship. Now be careful where you put the 18. If it's in the triangle over here, you're not correct. It is looking down. It's not in the triangle yet. Where can I put it inside the triangle? Where can I put it? Right. Because the angle of elevation of the boat is the same as the angle of depression from the top of that lighthouse. So now I've got that. What am I trying to find? How far is the ship to shore? Okay, so this is a little bit of drawing here. So what do I have here? This one's 18. Again, these are all tangents. That's no fun. So tangent of 18 equals 40 over x. X is 40 over tan 18. 40 over tan 18. 123.1? I want to the nearest meter, right? So approximately 123 meters. Yeah. Yeah, sure. If you pictured your lighthouse over here, and you see here with the boat here, that works, that's fine. Right? You'll have the same values. Right? You'll still make the same ratios. So that doesn't matter, as long as they're all in the right place. So questions? Great. Do a couple by yourself. Go ahead and try these real quick. I'm just going to give you a couple more. For those of you that are finished, I can show you what I got. How do we compare? Well, 37.1 is okay, except for what problem? So read the question carefully. If it tells you rounding, make sure you're rounding to what the question asks. I would have to take something off. I hate that. But I do want you to start learning to read really carefully because, not only because the SOL would mark you wrong, but also, if you are working on, there are future engineers in this room right now. I'm pretty sure of it, right? Anybody interested in maybe engineering? Yeah? So being precise is important. Reading directions, reading critically. What? You're engineers too, or I have a question? What? What happened? Yeah, that's good. Let's see, I wrote it down. I said the gross sign is 22. What? Wait, what are we finding? We're finding this, right? So is it wrong?
No, it's tangent. Oh, wait, no.
You're right. Okay.
Yeah.
Don't you think tangent is different? Tangent. You did tan 22?
Yeah, and then 15 over it.
Oh, it's different?
Yeah.
Oh, isn't that special? All right, well, there you go. Either one.
Triangle.
Yes. I don't know. Whatever your little algorithms they're using for figuring out the tangent and the cosine, that's a little bit different. How'd we do on this one? Now, did anybody challenge themselves to try to draw the picture without looking? No. The hard part for these is drawing the picture, right? You guys are getting pretty good at, I know how to use the working ratios, blah, blah. So now it's the drawing the picture. So you'll have some of these on the homework, so we'll work on those a little more. So now I want to kind of move on to the next little topic here. It's very much related to this, so hang on for a second. So inverse trigonometry. We use inverse trigonometry. Now what we've been working on so far with not inverse trigonometry, regular trigonometry, is we're basically finding sides. So you know an angle, you can use the ratios to find some missing sides. Well, what if I know the sides and I don't know the angle? Trying to find the angle. That's the inverse. Inverse means what? Opposite, right? So we use it to calculate missing angles in right triangles. We also are going to be solving right triangles, and I'll explain what that means to solve a right triangle. But like here, I've got some sides. I'm missing one side, but I'm missing some angles as well. I have no angles, but I have sides. So how do I find the missing sides? Like I know that the sine of this theta is this over this. Well, so what? How do I figure out what angle has that sine? So that's what inverse trigonometry does for us. Opposite. We know that we can use the trig ratios to find unknown sine legs. We'll learn how to use trig to find unknown angles. So if you're missing an angle, you use inverse trig here. It undoes the original function. Interchanges input and output values. Okay, you are going to learn about inverse functions, but basically, in a nutshell, here's a function. Y equals x plus 3. So let's make the little chart, right? Remember this?
Yep.
Good old days? Right, so if your x is negative 2, what's y?
1.
If your x is negative 1, what's y?
2.
It's 0.
3.
It's 1.
4.
And if it's 2. The inverse of this function, it's going to swap your y's and x's. So now your inputs, let's just call it inputs, are going to be 1, 2, 3, 4, 5, and your outputs are going to be negative 2. I am swapping. I'm taking the opposite. So basically it says if you were to graph this guy, oops, there's x plus 3. So I'm going this way, right? So if I'm swapping them, what happens to this graph? Yeah, what happens to it? It becomes reflected in what way? So, well, okay, well, let's just look at it. So you're going to get 1, -2, 2, -1. Oh, let me get this right. Yeah, 2, -1, 3, 0. That's something's wrong here. Oh, you know, these are kind of I don't think I did that one right. I don't know what happened to that one. But basically, it does turn it. It's more, I think it's like a rotation. Now, I know what sine looks like, so I'm trying to figure out what this looks like. Never mind. It does. You're right. So we're interchanging. So the idea is if I know the x, I can find the y. But what if I know the y? Can I find the x? That's what I'm kind of meaning to say here. If you know the x and you can find the y, that's great. But what if I know the y and I want to find the x that goes with it? Inverse. It undoes it. It does the backwards thing. Trying to look at this one. Oh my gosh, this is silly. Something that happened. Okay, never mind. All right, so you will learn how to do this in Algebra 2. Yes, I see what's going on. Never mind, I see what's going on. You don't, that's okay. Inverse trig function. It finds the angle that has the given trig ratio. So the regular trig is a function. This is what the sine function looks like. You read graph it. You know what a sine wave is? Anybody ever hear of a sine wave? No? In sound? Kind of have sound as travel in the sine wave. So this is a sine, what it looks like. So if I know this one is my x is 90 degrees, I know my sine value is going to be 1. So what I'm going to do with inverse sine is if I have a 1, I want 90 degrees. And it kind of turns it this way. I can't remember which way it goes. I think like that. It happens backwards. So it turns it upside down so it can find the angle who has the sine of 90 or has the sine of 1. So how do we write it? This little notation. This is confusing. All right. Sine of theta equals y. So if you have an angle and you take its sine, you get a value. So what does inverse sine do? It's going to find theta for you given a y value. And I'm going to use this notation, this little 1, -1. It looks like an exponent. It looks like, remember what an exponent of -1 does to you? What does it do? Like 1 over. So we're using it here to mean, and these are the words I do in my head, the angle whose sine is. Theta is the angle whose sine is whatever this value is. So what is this value? What's the angle whose sine is 1? What angle has a sine of 1? 90 degrees. So it's going backwards. Now, it could also be called an arc function. That's how I learned them. They were called arc sines. It means the same thing. I'm just saying if you see this in other places, arc sine and inverse sine, they mean the same thing. And some calculators say a sine. That means the inverse. Look at your calculator. Can you find where those are? So if you find your sine key, yeah, look up in the little second part, yeah. See that up there? So you get that by pressing the second button and then the function. So inverse function, inverse tangent. The angle whose tangent is y. Tangent with the -1 y could be arctangent y or arctan y. Those are all things that mean the same thing. If tangent theta is y, then the inverse of the tangent function for y is theta. Okay? So the angle whose tangent is 1 is 45 degrees. The angle whose sine is 1 is 90 degrees. The angle whose cosine is 1 is 0 degrees. So let's look at just some examples here. Find the measure of x. I'm just going to go a little fade here so I know where I'm looking. So, goodness gracious. So let's see. I have an opposite, right? What else do I have? An adjacent. So that means the tangent of theta, right, is 7 over 5. And now I want to turn this into theta equals, because that's what I want to try to do. It's pretty easy to do. What you're going to do is you're going to swap these guys around. So you're going to have the theta's going to be the outside. And now I'm looking for this value, but put in your inverse. So you swap these two values and put in the -1. And I read this as theta is the angle whose tangent is 7/5. And then how do I find that? I go to my calculator, and I turn it on, and I press the second key, and then I press tangent. Oops, and I didn't press tangent, I pressed tangent. The angle whose tangent is, well, how do I 7/5? Type it in, 7 divided by 5. The angle whose tangent is, what angle could that be? 54.5 degrees approximately. Find the measure of angle A. Now what do I know here? I've got an adjacent and I've got a hypotenuse. So cosine of theta equals 6/10. So now let's turn this into a statement where I've got theta equals. Well, you basically swap these values and you add a -1. So cosine, yeah? Yeah, you can put a name. Yep, that's fine. So it's the angle whose cosine is 6/10. And you just go to your calculator. So you go to the inverse cosine of 6/10. So that's the cosine. What's the angle? About 53.1 degrees. Don't forget the degrees. Find the measure of angle A. Now, I didn't even give you a picture here. All I know is the sine of A is 0.95. So how do I find A? What do you think, Michelle? I add 90? No, this is a strict, like I don't know the angle, but I know the value of its sine. Yes, 0.95. So if you don't know this, but you know this, you can use the inverse. It says swap them, but don't forget to put in your -1. And then once I know that, it's just a little calculator job. About 71.8 degrees. So I'm a little ahead of it. I'm just showing the calculator here. But are there questions with the calculator? And again, make sure. If you have to check it every single time, check it every single time. But make sure you're in degree mode, and then just the second and the trig function, and there you go. That's it. That's it. Example, find the measure of angle x. So let's see. This is my x. So I know the opposite, and I know the adjacent. So the tangent of angle x is 7/5. Then what? You did it already. These are the same exact one? Oh, okay. Don't have to do it again. We did. All right, now solving a triangle. What does that mean? It means find the measures of all the angles and all the sides of a right triangle that haven't been given to you. Well, it doesn't even have to be a right triangle, but for us it's going to be a right triangle. So we're going to solve this right triangle. What do I know? I know two sides, and I guess I know one angle too. That one's 90. So I want to find the missing pieces. So I have to find this length d of DE. I have to find this angle x, and I have to find this angle y. Let's find z first. Now, if I know two sides in a right triangle, how do I find the third side? How do I find it? Pythagorean theorem. So this squared equals that squared plus that squared. I always check, is it a perfect or a Pythagorean triple? Is it? Yeah, what kind of triple do I have going? Well, let's divide by 5 so you can see it, right? I see that common factor of 5. So that's like a 5, that's like a 4. Oh, so what's this one? A 3. It's a 3, 4, 5 triangle in disguise. So what do I multiply the 3 by? The 5 that I just divided by. So z is 15. Now, if you don't see it, no big deal. Use your calculator. You can do it in one step. Square root of 25 squared minus 20 squared. You can do that, that's okay. But it's more fun. You can find the triples. It's faster. So that's Z. Okay, so I found one of the pieces. Now I have two angles that are missing. So let's see. Write trig ratios for unknown angles. Let's start with angle X. So I know all the sides now, so I could use any trig function I want. However, why might I not use the 15? I might have made a mistake. So let's work with the ones we know. We know the 25, we know the 20. So what do I have here? An opposite, and I have a hypotenuse. So what can I say about sine? Sine x equals the opposite, which is 20, over the hypotenuse. So I know what the sine is, but I don't know what the angle is. What do I do? How do I rewrite this so that I have x equals? Right? What do I do?
X equals sine minus 1
Inverse sine, yep,
over 25.
20 over 25. I do, honestly, in my head I say x is the sine whose angle is 20 over 25. It kind of keeps me straight on that, because I get confused. Get confused too, I don't know. So let's see, we go here, I mean the angle whose sine is 20 over 25. Approximately 53.1 degrees. Now, is there a quick and dirty way I can find y once I know that? Yeah, how? Triangle sum theorem, or even the corollary to the triangle sum theorem. Remember what that is? These two things add to 90. So can I do 90 minus 53.1? Sure, why am I not doing it? Why am I not doing that? Why am I not doing that? In case I made a mistake. I'm telling you, I make mistakes all the time. You might too, I don't know. So let's work with this angle of straight. And again, I'm not going to use the 15, same reason. So can I come up with a relationship here? The cosine of y, right, is 20 over 25, because that's the adjacent relative to this angle. So let's see, what does that mean? Y is going to be the angle whose cosine is 20 over 25. Inverse cosine of 20 over 25. Inverse cosine of 20 over 25. And we get, now that's Thomason, 36.9 approximately. Degrees. Make sure you're writing degrees. It actually matters, because when you start moving into radians the next year or the next year after that, they don't have degrees. It's actually important to put your degrees in. You know what I do to check this? Add these up. Do you get 90? You do. So that's a good little check, that you got things correct here. Here we go. So that's it. That's not so bad. Let's do this. Now solve this triangle. Now this was slightly different. Now the last one, what did we have? I'm trying to find that one. One back? Yeah. The last one, they gave us two sides and said find the missing angles. What are they giving us here? One side and one angle. So to find the missing angle, what? Well, the 90, right? You're right. We have two angles, the 90 and the 51. So how do I find this missing angle A? Measuring angle A. What do I do? 90 minus 51. Why is it okay to do this now when before I said don't do it? Yeah. Yeah, they gave it to me. They're wrong, not me. Whoops, that's wrong. 90 minus 51. Actually, we should be able to do it on our heads, but let's try the other side. Now, don't forget degrees. Don't forget degrees. I think I'm taking off for that. If you forget degrees, I'm going to take off for it. It's important to, because we're going to have other ways to measure angles. Let's see. Now, write trig ratios for these unknown sides. So now I have the angle. Again, use this angle. Don't use the one you calculated in case you calculated wrong. So I'm going to use this angle to find B. I know an opposite and I know an adjacent. Right? Opposite, adjacent, and hypotenuse. So that's a tangent, right? So tan 51 is going to be my opposite, B, over 10.5. So that means that B is 10.5 times tan 51. Now all these things I'm writing, it is what I expect to see if I give you a problem, that you're showing me all this thought process. You're not doing any of this in your head. Right, 10.5 times tan 51. Approximately 12.96 Well, how does that round? About 13, right? And that's this guy. And now I want to find C, all relative to the things I know. So that's what do I have here, adjacent and a hypotenuse. Cosine 51 equals 10.5 over C. So this is swapsy one, right? So what does that mean? C is 10.5 over the cosine of 51. 10.5 over the cosine of 51. I'm working it. Whoops. Getting in the back, I cannot see these little teeny numbers here. About 16.7-ish? Now, how can you check this? Yeah, how would you check this? I would use the Pythagorean theorem. I'm gonna put those guys in here. You can tell I make a lot of mistakes because I'm always checking. Okay, so the square root of 10.5 squared plus 13 squared should be pretty close to 16.7 for me to be happy right now. And it is. So I check that stuff. Why not? Calculator, easy. And we answered this question. Why don't we use the new stuff we calculate just in case we make a mistake? If you don't have to, don't. Sometimes you do. But if we don't have to, I don't use it. All right, so this is for you now. Oh, there's a lot of them here. Oh, no. Yeah, I want you to practice now. When do you use straight-on trig function? When do you use an inverse? How do you find missing pieces? So I do want you to work on these for the next couple of minutes, okay? Okay, here's the answer to the first one. Answer to the second one. Questions on this? I realize not everybody has done them yet. So think about them a little bit. Okay, so for C and D, there was a correction here. Measure of angle C, 35.69. Let's look at the next couple of ones. Let's see how we're doing with these. Okay, so this is E and F, G and H. And if you want, we're running a little low on time. If you want to jot down the answers, and then you can go back and convince yourself that it's correct. KM, that length is 8. It's a little hard to read on your paper. And 40 degrees. What? I will in a moment. I just want to make sure everybody sees this before we run out of time, which is shortly. It's going to happen very soon. I'll tell you what, this video will be up, and actually the copy of the charts are on the class summary page with the answers. And I just want to kind of run quickly. I know you haven't finished copying yet. This is from the initial chart, so you can actually solve some of these too. Okay. So my suggestion, look at the class summary page. All these charts are there with the answers up for today's date, and you can find this.